Hi everybody, it's Miss Peachy from your WCA Earth Science class, and I am doing a video tutorial on your seawater density portfolio for Earth Science. So the materials you will need for this is 8 ounces of just plain tap water. You would need an egg that is raw. You need up to 4 teaspoons of table salt, and you need a container to be able to actually do your testing in. So what you're going to be doing is going to see how adding salt to the water affects the density of water. I want you to think about a couple of things in this, okay? Think about how density is the amount of mass in a unit of volume. That if I start out with 8 ounces of water and I add more salt to it, that I am increasing the mass of that water and I am slightly increasing the volume. If you have two objects, true things, and something is more dense than something else, so say something is more dense than water, it will sink in the water. If it is the same density as water, it should kind of suspend itself in the middle. And if it is less dense than water, it should float in the water. So we're just doing a comparison, more or less dense than the water here. We don't know the density of our egg, so that's something we're going to have to be able to kind of evaluate based on what we see here. I do not have a raw egg, so what I did was I improvised by using an empty medicine bottle and putting some clay in it and a couple of pebbles. I basically just added some weight to it until it just sunk to the bottom of the water. I didn't want to make it so heavy that it would never float, but I wanted to make it just less dense. Or excuse me, just more dense than pure tap water, okay? So let's go ahead and kind of start this portfolio. First thing you're going to do is pour your 8 ounces of pure tap water into another container. This is just preventing overflow, so it's not, all that important what the container is, but you want to make it so that the container isn't real shallow. Otherwise, it might be harder to gauge whether things are floating or sinking, okay? So here we have this container. I am going to do a little bit of fancy camera work here. Bring this down, bring my camera up so you can see it more on level. And I'm going to zoom in just a little bit as well. Also take off the light so you don't get the reflection. And again, down. There we go. That's a little bit better. So what I want you to notice is the first thing that you have is this water. According to the directions, let me go back to that for a moment here, tells us the water is 237 milliliters, and it weighs 1 gram for every milliliter. So we know this is also 237 grams of water. To calculate the density of the fresh water, you take the grams, 237, divided by the milliliters, 237, and you get a density of 1 gram per milliliter. So that's pretty much, pretty simple. That was given to you. Then we're going to check to see if our egg, I know mine's not exactly an egg, is going to float or sink. And what I want you to note is that mine sunk pretty fast to the bottom of the container. So I would write on this particular data table, I would record that it sinks here, okay? Now I'm going to add I'm going to add 2 teaspoons of salt to this water, okay? So I'm going to remove my egg, and I'm going to add 2 teaspoons of salt to the water. Okay, I'm going to stir this up, and you're going to want to stir it until there is no solid salt remaining. Remember, as I'm agitating it, I'm also adding air bubbles, so you're going to have to kind of take that into consideration and let it set for a little bit to get those air bubbles to kind of dissipate so you can tell whether it's cloudy or clear. Okay, so after time, once that settles, you're going to add your egg back to the water and you're going to record whether it floats or sinks. I'm not going to do that part for you, but I am going to help you with the math a little bit, okay? So 2 teaspoons of salt. Each teaspoon, according to the directions, is going to have a mass of, where is 5.7 grams per teaspoon. 5.7 grams per teaspoon. So let's do a little math here, okay? And make this a little bit bigger. But if it's 5.7 grams per teaspoon, and I have 2 of them, it's 11.4 grams of salt. Remember, I'm going to add that to my 237. That was the original mass of the water. So that gives us a new mass of 248.4 grams per 237 milliliters. Okay? So you need to get a calculator out and take 248.4, divided it by 237. Your number should be greater than 1, but not a lot greater than 1. Okay, but it should be greater than 1, and remember the units are grams per milliliter. So what you're doing right here is you take that new mass of 248.4 grams, divide it by the 237 milliliters to get your new density. And you're going to record whether it floats or sinks. Then the mass of the sample with 3 teaspoons means you're going to take this number, the 248.4, and you're going to add another 5.7 grams. Okay, add those together to get your new mass. So the mass is always going to be the mass of the water plus the additional salt. This particular portfolio has you go up to 4 teaspoons. But what if you get to 4 teaspoons and your egg is still not floating? Well, just keep adding a teaspoon at a time until you get it floating. And instead of recording all your new measurements, just record the one where it floats. And you can tell me how many teaspoons it is, if it floats, and what the mass of, the mass of the sample and the density. Here's the dealio, guys. There's going to come a point where the salt no longer dissolves in the water because it will become a saturated solution. When that happens, you are at maximum density. If your egg is still not floating at maximum density, it's not going to float because your egg is too dense. Very unlikely that would happen, but it might, depending on how big your egg is, if it's double or triple yolked and that kind of thing, okay? Now, what does it mean to float? It doesn't necessarily mean all the egg is above the water. Only a little bit of the egg needs to peak above the water line. If a little bit of the egg is peaking above the water line, it is considered a floating egg. If it is partway between, kind of suspended between the top and the bottom, then you've pretty much gotten to a point where your egg is the same density as the water. If that's the case, that's awesome for you because question 10 asks you to predict the density of the egg. So that density should be right where the egg kind of floats in the middle. It's not above the surface, but it's not touching the bottom either. Okay? Now, if you never get that to happen, you have to estimate. You know at what last point it was when it sunk, and you also know at the point where it floated. And you're just going to have to pick a number in between those two numbers as your estimate as to how dense your egg is in grams per milliliter. That's it, everybody, for your portfolio. If you have questions or concerns, feel free to give me a call at extension 2204 or send me a webmail message. Thank you.